Alright, so this is Unit 6, Goal 3 for Geometry, and we are talking about parallel lines and the proportional parts. So whenever we are cut parallel lines or have parallel lines, we're dividing into proportional parts. So if you see in this theorem, it says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional length. So AB, this part, over this part, or over BC, equals AE over ED. Also, it doesn't say that on here, but AC over AB would equal AD over AE. It's just as long as you're comparing and setting up your proportions so that those are equal, the same type of comparisons. So if I'm comparing the larger part to the smaller, then I need to do larger part to smaller on this side. So if those lines are parallel, then we're looking at proportional parts. So here's our first one set up, and we see that these lines are parallel by these here. So then that would mean 3 over 8 equals x over 12. So I did small to larger would equal small to larger. Then we can cross multiply. So 36 equals 8x, and then divide by 8. So x equals 4.5. There's quite a few ways we can set up this proportion. We could do 8 over 3 equals 12 over x. We could actually do 8 to 3. 8 to 12 equals 3 over x. So quite a few different ways that we can set up that proportion. We could even go 8 to 11 would equal 12 over this length, or 3 to 11 would equal x over the whole length there. So quite a few different ways to solve those. So then the opposite is also true. If the sides are cut into proportional parts, then the lines are parallel. So we can check to see if they're parallel by checking their proportional parts. So here we have DH is 18, HE is 36, and DG is 1/2 of GF. So whatever GF is, DG is half of it. So we see that 1/2 over GF, 1/2 GF over GF equals, we're checking to see does that equal 18 over 36. And really what happens is this 1/2 is my scale factor. So does 1/2 equal 18 over 36? So we could reduce this fraction, or we can cross multiply and check that way, which we see does 36 equal 36? Yes, so they are parallel. All right, let's look at it with side lengths, and again we can look at holes, but just make sure that we have the whole length on both sides when we're comparing them. So they want to know, does XY, which is 15, and YZ, which is 25, does that equal WA, which is 18, and 32? So we would set it up as, it does 18 over 32 equal 15 over 25. So again, we could cross multiply. Let's reduce this time. Let's divide both of these by 2, so we get 9/16. Does that equal 3/5? And this would be no. So that means the lines are not parallel because the sides are not cut into proportional parts. So they're not parallel. All right, we also see that a mid-segment, so a mid-segment is a line that cuts the sides in half. So this side equals this side, this length equals this side. It's parallel, which makes sense because the comparison of these parts would be 1 to 1, 1 to 1, because they're equal. So when I put the fractions over, we would get 1. And the length of JK, of the mid-segment, is half the length of the line that it's opposite of. So if FG was 10, JK would be 5, and so forth. So we're going to figure out a few things here. First, we're going to find AB. So we know that DE, this line, is a mid-segment. So it's opposite of AB, but it cuts this side in half. And we also know that EF is a mid-segment here too. So those are both mid-segments by what's in here. So first we need to find AB. So if we look at the mid-segment, its length is 5, which should be half of whatever AB was. So AB would be 10. Next, we want to find FE, and it's a mid-segment, so it is half of the side opposite of it, so of BC. And BC is 18, so this would have to equal 9. And then angle AFE, because these are proportional and it's a mid-segment, that makes these lines parallel. And AFE, this angle, with this angle, would be alternate interiors. So this has to be 87 degrees. So again, mid-segment, so this is 8, so this would have to be 16. This is 15, so this has to be 7.5, half of 15. And this angle here would have to be 122. So we kind of went through a few of them there, but those are the things that you're going to be asked for on the mid-segment. So the halfway line is half the distance of the line opposite, or the mid-segment. And then we want to look at proportional parts. If we just have parallel lines and they're not a triangle, 3 or more parallel lines intersect 2 transversals, then they cut off the transversal proportionally. So notice these lines intersect this transversal and this transversal, and so these parts are proportional, AB to BC and EF to FG, because this distance is the same between them, so that makes those parts proportional. So since these blocks are these in the figure, larch, so this street, maple, and nuthatch are all parallel. So these lines are all parallel to each other, which means that these transversals are cut into proportional parts. So 26 over 13 will equal x over 16. Again, we could reduce this to 2 over 1 and then cross multiply. So 32 equals x, so x equals 32. Let you work on that one. And the last part is that if the one side of the parallel lines, the transversal is cut into even parts, then the other side would have to be 2, because these again are 1 to 1. So this would have to be 1 to 1, and we learned on the last part that if they're all parallel, these are cut proportionally. So AB is equal to BC, then EF is equal to FG. So we're going to use that to find x and y. So 3x minus 7 equals x plus 5. Subtract our x. 2x minus 7 equals 5, and then add 7. 2x equals 12, x equals 6. And we can do the same thing. Since these are equal, then these two are equal to each other. So 9y minus 2 equals 6y plus 4. Subtract 6y. 3y minus 2 equals 4. And add 2. 3y equals 6. Divide by 3, y equals 2. All right, hopefully that helps with your lesson.